Hey there, my name's Alejandro, and welcome back for day 219 of me doing Daily LeetCode challenge after I reach 1 year's worth of green contributions here on GitHub. So today seems like we got a very beautiful badge here. Congratulations, 50 days badge of 2025. I'll press generate image for later, just so that I have that in my records book. But yeah, this feels pretty nice and handy dandy. But nevertheless, without further ado, let's get straight into problem 219 for February 20th, 2025. Okay, so today we get a LeetCode medium problem 1980. Find unique binary string. Given an array of strings nums containing n unique binary strings, each of length n, return a binary string of length n that does not appear in nums. If there are multiple answers, you may return any of them. Wait, really? Okay, the very first thing I'm going to do is just convert num set is equal, or nums equal a set of nums for O1 lookups. Can I just not just enumerate num equals 0 while lambda num to binary string bin equals or I could even just do I could just convert these into decimal, right? Here we'll do s is equal to set of map, comma nums, and here we'll do lambda num into int num, comma 2. Num equals 0, while num in s, num plus or equal to 1, return num. We probably gotta return the binary string representation of that, right? So we'll do bin of num from 2 onwards. No. Expected 0, 0. What? What's it talking about? Okay, do I just do from number 1 then? It doesn't say smallest, right? Oh, binary string of length n. If anything, I could put everything into a try. I don't know, and not just get something that doesn't exist. If there are multiple answers, you may return any of them. Yeah. Okay. I mean, one way is we could just backtrack again. What's the input size of this? Okay, bruh. All right. Okay. Is this really just another backtracking problem? Okay. Okay. Welp. Okay. Okay, I guess it's a backtracking problem. Band is equal to this. So here we'll do for here we'll do backtrack. Def backtrack. Here we'll do n. N is equal to length of nums. Then here we'll do yield string.join array, right? And here we'll do band is equal to set of nums and return, right? Otherwise, what we're going to do here is back for in 0, 1. In 0, 1, you will say right. Here we'll do yield from this guy, and just return, right? While bin string equals backtrack turn bin string oh gosh. Print f string equals. Okay, here we'll just do list. Print f string enumerable equals. Okay. Okay, that works. Okay. And obviously I can't do this, right? Because otherwise it'll just recall it. Yeah, infinite loop. Okay. Okay, nice. Okay. Okay. Let's run this. Okay, submit. And there we go. Completion streak 219 days. Consistency is key. See ya tomorrow. Okay. So here we only be 29% with 2ms. We'll have to see if we can do this a little bit faster. Yeah. Ooh, here we could just do bin string equals string.join if are in band not in band yield r return yield bin string, but no matter what we return yield from this, right? And so now here we can make this print f string enumerable and return enumerable of 0, right? Something like this will work, first of all. right? But now we have a solution of all the valid possible values, right? So here I could do random.randint 0, length of enumerable, right? And here let me do, oh, this is from the previous day. Import random help random.randint. Okay, A to B. So here we'll do this -1. Yep, right? And something like this will work. Yep. 0, 0, 0, 101. Yeah. Sweet. Output limit exceeded, understandably so. Yeah, obviously very, very slow, but we don't need to do that. We can just make this backtrack and return next of enumerable. All valid solutions, i.e. ones. Enumerable of all valid solutions. There we go. Nice. Sweet. Submit this guy. And there we go. 0ms. Bada bing, bada boom beats 100% of solutions. Yeah. So we might as well only return things that are not in band directly, right? That way we have an enumerable. Yeah. So here we'll do valid solutions is equal to backtrack. Return first result. Right, and that way, yeah. So, okay, that's nice and convenient. There we go. We can submit again. Well, that would explain it, right? If you change the name, you use that changed name. All right, now we get 4ms beats 21%. But yeah. There we go. 0ms beats 100%. Bada bing, bada boom. That is absolutely what we love to see. Okay, so nevertheless, as always in all my videos, I do a quick recap if I was able to solve the problems. For this one, I was trying to devise something clever to do at the very beginning. It's just that at the end, I ended up realizing that n is teeny, weeny, tiny. So we can just do regular old backtracking. What this problem asks you is essentially find, give me any binary string of length n that is not in nums, where nums is an array of binary strings of length n, right? Easy peasy. So the way we do this is, first of all, we're going to convert nums into a hash set called band of the strings instead of nums. Why? That way we can look up in O of 1 time if a string exists inside of this band set, instead of O of n time if we use nums, right? If we kept this as a regular nums and we press submit, we'll notice that our code will be a lot, okay, I guess it's fast enough, just because how long is nums? Yeah, n is at most 16. Okay, so it won't be too terrible, but we might as well make it a hash set, because why not? That way we keep it O of 1, even if nums was like, unbelievably large, and that's how we get that 0ms solution. So that's the very first thing. We're essentially going to enumerate over all the possible binary strings of length n, and just have a backtrack function to essentially go through every single, permutation, because every single, position out of n positions can either be a 0 or 1, right? And so there's going to be n factorial total permutations that you can have. And so, that's if you it's going to be for each one, you have 2 possibilities. So it'll be 2 to the n possible permutations, all right? And so the way that you're going to essentially, well, the way that I do this is essentially I just enumerated over every single possible binary string of length n, and return the very first, well, this is a function that returns all valid strings of length n, binary strings of length n, that are not in our band set, right? So essentially, here this backtrack function, it'll use this termination case, like, okay, if the length of the array is equal to n, we'll do some stuff, but we'll return, right? We won't backtrack from this point anymore. So like, this is a termination condition. And then here we'll take, okay, whatever's in our array, which we'll put in either zeros or ones in there, or, it'll be a list of zeros and ones. So if the length of the array is equal to n, then we essentially have an array of zeros and ones. So we'll stringify that, turn it into a string, right? And then we'll say, okay, if the binary string is not in band, that means it's a valid one, right? So we'll just yield return that string, right? So that way this backtrack function essentially gives you an enumerable of all valid strings, right? And that way I can essentially create an enumerable and just return the very first value, right? Obviously, if I converted this into a list, right? Here, if I did list and I return to you return valid solutions of 0 here, I can definitely do that. It's just that we'll see that this code is very, very, very slow. Right? I take beat 5%, 2200 ms, right? Because here I'm enumerating over all possible valid solutions, right? Versus if I just do this and I just I make it an enumerable and I yield return things as I go, I only care about any solution and returning that solution, right? In this problem, it says you may return any of them if there are multiple answers. So here's just like, I'll have this backtrack function where I yield return elements and I'll just return the very first one. So I'll just do, I'll create this enumerable and just return the very next value that I get, right? That's pretty much literally it, right? And here I'll press submit, and obviously we'll do a little bit better than 2291 ms. We'll get 1 ms beats 31.88%, right? So, hovering over that like between 0 and 4 ms range. So like, if we resubmit a couple times, we might, yeah, there you go, 0 ms beats 100%, which is what we like to see, right? So this is just basically brute force, right? And again, the way the code works is like, if it's valid, then we'll yield return it. Otherwise, it's like, okay, let's keep backtracking, right? For every single digit between 0 and 1, we'll say, okay, append that digit into our array. Here it's like, okay, yield from backtracking from this point forward, right? So it's like, let's say we put in 0 in the array, let's keep backtracking from that point on. If there's anything from that point on that is valid, then like, we'll yield return elements from there. So that's why we do yield from backtrack. And then finally, like once we've gone through every single thing inside of there, we'll just pop and like, move on to adding a 1 instead, right? And then once we're done with that, then we're done with either case, right? Because at whatever position array we were at, we can either put a 0 there or put a 1 there, and then continue from either of those cases, but we can't do anything other than 0 or 1, so then we stop, right? That's kind of the idea. And again, since we're using yield returns, it's an enumerable that'll keep going back to the function every time you want to get the next element, but here we only ever call next once because we only need one solution, not all of them, so that's pretty much it, and that's why it's a lot faster, because we don't need all the valid solutions, we can just have one. But if you wanted all the valid solutions, you can just return the list of valid solutions, and there you go, chop chop, bada bing bada boom, you have a nice and efficient working solution. But hopefully this solution makes sense. It's just backtracking like we've done in the couple previous days in the Daily LeetCode challenge. We've been getting a crap load, not gonna lie, of backtracking problems. So hopefully soon we start getting something else, because we got our fair share, but time to move on a little bit, LeetCode, if possible. But yeah, it's a nice at least it's a nice little relaxing break, a little bit of backtracking ain't never hurt nobody, right? So well, okay, if you're not familiar with backtracking too much, this might be a little bit difficult. The way that I essentially was able to learn backtracking, because it was actually a weakness of mine, was inside of this LeetCode 150 playlist. Just doing these backtracking problems over here kind of really helped me understand how to do backtracking a lot better. I actually really learned from doing these problems, and now backtracking is just completely mostly intuitive to me. So there we go. Very nice. And we get to practice some sick yield returning, which is pretty cool and awesome. This is something, you never know what you end up needing to use in LeetCode. So to use something like yield returning in LeetCode is actually pretty funny to me. But nevertheless, that's pretty much it for this video. If you did find it useful and enjoyable in any way, shape, or form, I'd highly appreciate it if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.